All right, welcome everyone to your review session for your final exam. Your part one of your final is a 20 multiple choice question test. You're allowed 2 hours to complete the multiple choice assessment. But frankly, you may not even find that you need an hour for the assessment. It's literally 20 multiple choice questions in Lumen. You won't have to print anything out. You won't have to write anything down and submit it. Nothing like that. You literally will sit in front of the computer and you'll take the assessment with me, just like we are right now over Zoom. So that's kind of like the whole experience. You will have to have audio and video when you're taking the test. Of course, I have to make sure it's you. And of course, I want to make sure that you're not getting any assistance or things like that. Once you are completed with the 20 multiple choice questions, you'll have one final question that says, hey, did you do this honestly? You select, yes, I did. And then you move on and you're done with that part. So that will happen tomorrow on 5/24 from 10 to 12. And again, you may find you don't even need that full duration. You may have a formula page front and back filled with whatever information you need. Even if we were meeting in person in a regular session, you would still have access to a formula page. So feel free to make one or to use the one that I have. I know the one that I have scanned really weird. So if you feel better, make your own formula page and you can use that for the test tomorrow. Your part two of the final is due tomorrow night by 11:59. So for your part one multiple choice assessment, the only thing you can have and should have on you is your one-page formula sheet. You will not be using your notes. You will not be using any outside resources for the part one of the final exam. All right. A formula page should be more than enough resource for you to be able to answer the questions that are being asked. So Manny, hopefully that answers your question. Someone had a hand raised. Anna, did you have your hand raised?
That was, so it's just the formulas. We don't need like those chart, like the Z-score chart.
No.
Okay.
And if you needed any of those charts, I will provide those in the actual assessment itself.
Okay. So for the multiple choice, is it like, because for some of the homeworks we had it where it's like definitions sort of kind of thing, and then we had to like pick one of those. Is it like that, or is it like you have to work? So is it?
It's a mixture of both. So maybe some questions, it'll be more like, select the best description, or other questions will say, actually perform the indicated calculation, right? Like perform the statistical calculation in this case. So you will have a mix of both. But again, it's only 20 questions. I can't ask anything real deep and intensive, which is why you have a part two. As a lot of you have already seen with the part two, do you notice that they're pretty intense questions with like a lot of work that needs to be shown, a lot of description, that kind of thing. So that's why I wanted to separate the two. So the part two is where you do your extensive descriptions and you show all of that work, you show the process behind your calculations. Whereas with part one, it's a little simpler. A little bit more straightforward, which is why I said most students actually tend to finish this within an hour. It's pretty rare to need the full 2 hours for the 20 multiple choice question assessment. Money.
So I had a question, like I never took any exam over the Zoom, like how would it work? Like would we like open the Zoom and then minimize it and then go on Chrome and then do it like that?
Yes, absolutely. It would be like what we're doing right now. And then you log into Lumen, the assessment will open just a couple minutes before 10 a.m. so that everybody can have their Lumen set up. And then at 10 a.m. you'll begin.
No, like so like if my screen is minimized, like would you still be able to like see me, or I have to like keep the Zoom open?
I can still see you.
Okay, gotcha.
Yeah. Like if you did have your video on right now, you can look at other assessments, whatever, and I'd be able to see.
I didn't know where that sound was coming from. I kept telling Alexa to turn off.
Okay, perfect. All right, Allegra.
I have a quick question about
Go for it. Oh, you can use any calculator you want. Yeah, there are no restrictions on the calculator because we don't do anything that would violate, you know, the use of a more advanced calculator in terms of like what we expect for a course. There's not much you can do, right? Other than like plug in values and then do the actual calculations. It's not going to run analysis for you. We don't have any graphing, so that's not even a worry. So you can use any calculator you would like. I think I caught that. I'm trying. Yeah, I don't know why the sound is a little bit off. So you're referring to your greater than or less than values. I'm trying to think if there are any specific questions where you will have to actually input the greater than or less than, because you know how Lumen usually has your inequality and it has the symbols built in and you just kind of fill in the ends kind of thing. So I think if you saw any particular questions pertaining to like, you know, maybe an interval or something like that with our confidence intervals, you'll only have to write in the values on either end. One of the things you should think about is the range rule of thumb as well, right? So with range rule of thumb, if you are asked to round, you want to make sure that your values are in that range. If they're outside of the range, then they're not within, right? Like, so we want to be really, really careful that we pick values that are specific to inside the range of values that you calculate. Just be careful with that, because I know sometimes we make that error. Like for instance, I'm going to put something in, actually, I will put this on the whiteboard to show you what I mean. What if, for instance, you calculate your range rule of thumb, Mani, you won't need Excel. You'll calculate your range rule of thumb, and let's say you had 41.32 comma, and then 67.97, right? Something like this. If you had to decide your usual values, do you see that when we think about our calculations that, and I can't move that over, but your smallest value here is actually a 42, not a 41. The reason we say that is because 41 is outside of this range. 41 is out here, right? And then if you think about being outside of the range, your upper bound 68 is outside of that range. So when we think about answering for the range rule of thumb, we can't use 41 and 68 because that doesn't make sense. They're not inside the range. So when you say your usual values, in this case, you can say the usual values lie between, let me move this over, lie between 42 and 67. And that's how you would essentially answer that particular question. So it's not so much about less than or equal to or those inequalities, but what rather staying within the range. And I think that's about the extent of it in terms of when you think about what values to include or not to include. Does that kind of answer your question, Allegra?
Yeah, actually, that cleared a lot of things up. But I was specifically asking about like when you're trying to figure out both hypotheses versus the whole
can you disconnect your headset and then maybe ask your question off of the headset and just using the mic from your computer, because that whole last part is just completely wiped out what you were saying. Or you could type it into the chat too if it's not working. Mani, and again, to answer your question, you will not need Excel for your part one, so you don't have to worry about that. You just need your formula page because that will help you to perform the indicated operations. And while Allegra is fixing that, Anna, go for it.
Well, I actually have a question. So I'm at work right now and I just had to pick up a call. So what, I know we're reviewing, but like, is this one of the ones that will be on the part one?
Like a possible rule range of thumb? Yes, it could be. Because the formula for calculating the rule, the range rule of thumb, my gosh, is essentially take your mean and you subtract 2 standard deviations, that's your lower bound. You take your mean and you add 2 standard deviations, that's your upper bound. So as long as you have that formula on your formula sheet, you should be just fine. You'll just literally take those values and plug them in.
So because I printed the two, because the section where it said final on Lumen, I printed out, I think it was the formula and then the charts, because I haven't done the part 2 yet. Will that formula be on like this scan written out part?
So you are referring to in Lumen, let me go in here real quick. Give me 1 second. You're referring to in Lumen, this part 2?
Yeah, so if you go up a little bit, it has the formula page.
Oh yes, here, you can print that out. You can use it.
Okay, so
I know it looks like
that,
crap, but you can totally use it.
so that formula that to figure out that question will be on there, on that sheet.
Yes, I'm pretty sure the range rule of thumb is on here. Is it? If it's not, you can add it. There it is. It's right here. Range
Okay,
rule.
so it's the mean. Oh, okay, we've had other ones
Yes.
where it's like that. Okay.
Yes. Yeah, actually, we've seen range rule of thumb quite a lot in this course.
Because we had it where recently for some of the homeworks where you had to do like the mean minus 2 times the
Standard deviation.
standard deviation. Okay, so that's what that is. Okay.
And mean plus twice the standard deviation. Good. Good. So yeah, you can totally use this sheet. You can add your own stuff. You can create your own from scratch. It's completely up to you. It doesn't matter. It'll just be a single sheet of paper front and back.
Okay.
Good. Good. Awesome. Let's see. So let me stop sharing this screen. Okay, so if a question that requires finding a null alternative hypothesis needs to be less than or more than, but provides an alternate statistic that is smaller or larger than the null hypothesis, do we resort to not equal to, or do we use less than or greater than? Oh my gosh, okay, that's a great one.
Sorry.
Allegra, for your part 1 of the final, I don't think I have any questions pertaining to testing a claim, so hypothesis testing, because that's in our part 2. That's a very extensive process. As you know, there's multiple parts to this. So I will say with 99% certainty, you will not have that kind of a question on your part 1. Awesome.
Thank you.
You're welcome. Very, very nice. Muna, that formula paper from Lumen, yes, absolutely. It doesn't look great, but you can totally use it, or you can create your own. Good. Very nice. Mani, in terms of calculating the values, you should know how to calculate mean, median, mode, mid-range, those kinds of things, range by hand. You do not need Excel for those. So if I were you, I would make sure your formulas are up to par. That way you can actually calculate them by hand for the part 1 if you need to. Okay. Good. All right. I think that takes care of all the questions pertaining to part 1 of your final assessment. So let's take any questions you may have. Is there anything in particular you'd like to see? Maybe something from the review packet, et cetera, et cetera. Anna, start us off.
So that question that you had up where it had, I can't remember what it was. It was the range rule of thumb. Can we do that as an example?
Like a
Like,
range rule of thumb question?
yeah, can we like work that one out?
Yeah, let me see. I'm gonna try to find one from our packet maybe that has a range rule of thumb, or we could do one from the homework assignment. Let's see. And hopefully you all have had a chance to go through the course review packet. That's going to be very, very helpful. Okay, so let me go into Lumen, and we have the range rule of thumb. Let's take a look at where this is. Here we go, in Unit 3. So let me share my video. Let's go here. Understanding Z-score and range rule of thumb. Let's preview this. Okay. We don't want the Z-score, we want the actual range. Here we go, perfect. Okay, so this would be a good example. The first thing we would want to do is we want to calculate the mean. So how to, actually, Mani, this question is for you. How do you calculate the mean? Mani, do you know?
Hello.
Hi.
Hi. So you said mean.
Yeah, how do you calculate the mean for this?
I'm not gonna lie, I actually use Excel for like every single thing, so I'm not sure how to do by hand.
Okay, okay. Can someone back Mani up? Because this is pretty important. He needs to be able to do this calculation without Excel. Can you help him out? How would he do this?
I can do it. You add up all the numbers, and then I'm not sure how many there are, but then you divide it by how many numbers there are. 2, 4, 6, 8,
Perfect.
11. Maybe?
Yes, perfect. So when you calculate this, notice you should be getting 47.82. So Mani, you'll add up those values together. There are 11 values. So you divide that value by 11. You should be getting 47.82. In terms of sample standard deviation, again, for something like this, I would give you a smaller sample size to calculate this by hand, but I can demonstrate to you. I'm going to use Excel because I need to be able to write stuff down, but you will not need Excel for your part 1, I promise. So let me demonstrate to you how you would calculate the standard deviation by hand. Anna, do you have a question while I do this?
No, I sort of remember how to do the mean. It was just like the range rule of thumb, I believe.
Yes, that you're calculating. So in order to find the range rule of thumb, we have to have the mean and we have to have the standard deviation. So we're just going to do that really quickly. So in order to, for instance, calculate the standard deviation by hand, you are going to simply list all the values. Notice that I have 11 values listed here. The next thing we have to do, no matter what, is we have to calculate the mean. The good news is we calculated the mean already, and we found that that was 47.82. Using this information, we're then going to take each value and subtract the mean. So I'm going to do this using Excel, obviously, because I want to be able to show you the process. But we would be actually calculating this by hand. Anne or Anna, whoever was first, do you have a question?
No, sorry, I never took my hand out.
Oh, that's okay. How about you, Anne?
So I just want to make sure, right now you're showing us how to do the sampled standard deviation, right?
Yes, perfect.
Okay.
Yes, beautiful. So to calculate the sample standard deviation, you're going to take each raw data value and you're going to subtract the mean. So for instance, this first one was 60 minus 47.82. The next one is 59 minus 47.82, and then so on and so forth. So we calculate each of those differences. The next thing we do is we take each difference and we actually square it. So keep in mind that when you square a value, positive or negative, your result will always be positive. So we're going to take our results here and we are going to square it. The nice thing about Excel is that I can simply drag it down and it'll just calculate that for me. The next thing we're going to do after we square each of those independent values, and remember this is being recorded, so I will upload this video for you all to see later. The next thing we would do is we would actually add all of these values. So I'm going to call, let me move this here so that I can have that room. Okay, so now we're going to calculate the sum of everything in this column. First, let me make this a little bit bigger. I just want you all to focus on this one, and we're going to calculate the sum of all of these values. Here it is. We're then going to take this value and divide by 1 less. Remember that when we calculate standard deviation for a sample, you take the sum, you divide it by n minus 1, not just n. You divide by n if it's a population. The good news is when we see our samples on our test, we will be dividing by 1 less than the number of values we have. So we're not dividing by 11, we're dividing by 10. So let's say that this is the sum over n minus 1. So we're going to take this value, and you can verify this. You can punch this into your calculators. We divide that by 10. And then to find the standard deviation, all we have to do is take the square root of that number. So we're going to take the square root of this value, and we find that our standard deviation is 29.23 if we round to the nearest hundredths. Okay, so 29.23. We can go on here and we have our sample standard deviation. Now, in terms of range rule of thumb, let's do some math here. We know that to find the minimum value, that's going to be found by taking the mean and subtracting twice the standard deviation. I can't type. So the mean in this case is 47.82 minus 2 times the standard deviation. The standard deviation was 29.23. So we're going to go ahead and punch this into our calculators. So 47.82 minus 2 times 29.23. So we find, that our lower value is going to be negative 10.64. This is our minimum. We're going to do the same thing, and this time calculate our maximum. It's the exact same formula, except you're adding 2 standard deviations instead of subtracting them, of course. So we have 47.82 plus 2 times 29.23. So let's punch this in here. 47.82 plus 2 times 29.23. That means our maximum value is a positive 106.28. And then when we think of your range rule of thumb, you want to consider your possible values and how to actually input this. So notice it says it would be unusual to have values smaller than, and notice that we had negative 10.64. I believe it would accept negative 10.64, and even if it didn't, it was off by 100ths, I would still go back through the final exam and I would give that back to you. Okay, so I don't want you to freak out about that or worry in any way, shape, or form. So we can say negative 10.64 would be unusual to have values smaller than that, or it would be unusual to have values larger than 106.28. Okay, and we can input both of those values that we calculated. Does that help at all in terms of calculating the mean, standard deviation, and then using that for the range rule of thumb? Are there any more questions on this for whoever asked? Okay, hearing none, I feel like you guys are okay with this.
Will we have to calculate the sample standard deviation at all on part 1?
If you do, it's for a very small sample. It will not be anything for more than like 6 digits or 6 values, excuse me.
Okay, thank you.
You're welcome. Good. And Mani, you'll be just fine. You can do this. If anything, Mani, before you take the final tomorrow, just practice a couple times. And I have this covered in the video. We do this by hand in unit 3. So I would go back and just double check to make sure that you feel confident with calculating standard deviation. Okay. Good. All right, very nice. Who's next?
I had a question.
Hi, Mohammed.
Hi. I kind of struggled on the last 2 units. So is there any way you could go through like one of the longer homework problems from like the last unit?
Yes,
like
unit
the
8 and 9.
Yeah.
So here's the thing. You won't be tested on that on your part 1 of the final exam.
Okay.
Because they're so extensive, there are multiple parts to each of those questions. That's why you won't actually see that on your part 1. That's why I specifically wanted to include that in your part 2, where you'd have an opportunity to break everything down.
Gotcha.
Okay, so I mean, we can still look at a problem, but I'm a little bit nervous to take away some of your time for a question you won't even see on the part.
Yeah,
1.
no, I understand. That's fine.
Okay, all right, cool.
Thank you.
Yeah, of course. Yes, describing the shapes of histograms. Cool. So course review question number 14. Very nice. And I believe I have that course review open, and you said question number 14. So let me go ahead and I'll share my screen. You can also open up the course review packet. Let's share my screen. Give me 1 second. Trying to open everything up. Course review questions for 160. Here we go. So number 14. When you look at this particular histogram, I want you to kind of overlay a curve, and I'm going to do my best to draw over this. It's probably not going to look that great, but I'm sure it'll suffice. So when we look at this together, do you guys see this shape? And then like this, like this, like this, like this, like this. Do you see that shape? Does anyone remember how you would describe the shape of this histogram? And then can you explain why? What do you think?
Skewed to the left?
Yeah, it's skewed to the left. How do you describe to someone like how you knew that? How can you verbalize in words that you know it's skewed to the left?
Because the left-hand side has the longer tail.
Ah, so we have a longer tail here on the left-hand side. So it's skewed to the left. Very nice. You would have a skewed right distribution if it looked something like this, where the tail is on the right-hand side. So it's kind of, in class, we talked about like putting a person on the top of the hill and then saying if they wanted to be safe, which side should they ski down? I know it's a little bit silly, but here you're skiing down to the left because it's a gradual tapering off. For my second drawing, my second terrible drawing, you're going to ski to the right. So it's skewed to the right. So hopefully that kind of helps to make things a little bit more sensible. Uniform distributions are essentially where all of your bars are practically the same. So if you looked at a histogram, they'd all be very, very closely aligned. So it's a uniform distribution. If it were a bimodal distribution, that's essentially a histogram where you have 2 peaks. So you have 2 modes, bimodal, 2 modes. So you would see 2 separate peaks, okay? And then of course your normal distribution would simply be your bell curve. It'd be the one that we have been using every time we talk about like the z-scores and things like that. So it's something like this. Here's your normal bell-shaped curve, okay? Does that help at all, Jay? Score. Okay, very nice. And that's a good question. You might see one on your part 1 that asks you to describe the shape of the distribution. Good. Very, very nice. I want to add a follow-up question to this. So looking at what I have here, so not my second drawings, looking at our graph here, which value of central tendency would be higher? The mean or the median? What do you think? Do you remember? Okay, let me describe this for you. The mean is very, very sensitive to extreme values, right? Think about if you have a neighborhood of houses and then all of a sudden one house is rebuilt and it's like twice the value of all the others. If you took the average of all of the houses, it's going to drive the average up. It's going towards the more extreme value. Similarly with a value that's really, really small, the mean is pulled towards those extreme values. So if we had to guess at where the mean would be and where the median would be, the mean is actually going to be a smaller value than, let's say, the median. Okay. So when you have values that are skewed to the left, the mean is pulled towards the smaller, those extreme values, right? Extreme meaning really, really low or really, really high. So it's pulled towards those smaller values, which implies that the median is actually going to be a higher value. Okay, so if you have to think about which one's higher, just remember that the mean is pulled towards the extreme values. So vice versa, if you had your curve and it was, for instance, skewed to the right, you can say that your mean is pulled towards the higher values and your median is going to be smaller than that. So the mean in this case is a higher value than the median versus skewed to the left. Something to think about. Remember, the mean is pulled towards the extreme values. It's very, very sensitive. Anna.
So, sorry, I just had another call. So, I know how to do like the skewed left to the right, but for the part with the median and what you were just talking about, is that going to be on the final?
You could potentially see that, yes. Yes, and it would
Okay.
just be asking which one's higher.
The mean is in the middle, correct?
The mean is the average of all your values. The median is the exact
I mean-
middle value.
I mean the median, sorry.
Yeah, that's okay. Okay, keep in mind, and if you watch this video back, you can kind of hear the language again. We also have this covered in our notes where we talk about the distributions and we describe that pull from the mean. Okay. Good. All right, who is next?
Can we go over question 20 in the course review?
Yes, perfect. I looked in the chat and it like said course review number.
I didn't realize I had that typed out.
That's okay. All right, number 20. So 76% of sunflower seeds will germinate into a flower, and a sample of 800 such sunflower seeds is randomly selected. The standard deviation for the number of sunflower seeds in such samples of size 800 is, okay. So when you see questions like this, what jumps out in your mind? Tell me some things that might, jump out at you.
The p hat or like success rate is 0.76.
Okay, so wait a second. Let me annotate. So you're saying the success, the P is 0.76. And follow that up. What else does that tell you?
Tells you your Q.
And
Yeah,
so,
Q 0.34.
aha. Okay, so we have probability of success, 0.76, that the sunflower seed will germinate into a flower, and then probability of failure, which is 0.34. And you know this because together, collectively, they add up to 1, which is total probability. Okay, you're given a sample of 800 sunflower seeds, so that's going to be our N. So when we think about this kind of a problem, I want you to think of a yes, no. Yes, it'll turn into a flower. No, it won't. And if it's a yes, no situation where you have two possible outcomes, we're directly referencing the binomial distribution. Now think back to the formulas for calculating mean or standard deviation for a binomial distribution. Does anyone have that formula handy? I would like the standard deviation one. Take a look at your formula page. You might see it there as well. Anna, while people are looking this up, do you have a question?
Yeah, so how do you get the 0.34 again?
Cindy or Allegra, would you answer that for Anna? How'd you get 0.34?
Your P and Q together always have to add up to 1. So I'll always take 1 in my calculator minus whatever P is. So in this case, 1 minus 0.76 equals 0.34.
Awesome.
I got, wait, so then if you wanted to like check it, you could just add those two together?
Yes. Oh, I'm
I
sorry.
got
It should be
1.1 though.
0.24.
Yeah, I was thinking, wait.
Oh, whoops, that's my
That's why I
fault.
had,
That's
that's
my
why I
fault
got
too.
confused, because
That's
I
my-
remembered that like someone said you subtract like 1 times or
Yes.
minus P,
Yes.
and I was like, wait, okay.
Thank you for pointing that out. That's my fault. I totally was like not even doing math in my head. I shouldn't do it like that sometimes at all. Okay, good. So what is the formula for the standard deviation of a binomial distribution?
The square root of NPQ or N times P
Yes.
times.
Yes, I love it. So we've got the square root of N times P times Q. So we have NPQ, and we are going to just put the square root outside of that. Da, 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 ba, 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 and then I just want you to punch that into your calculator. Please be careful. Punch in N times P times Q, and then take the square root of that answer. Or if your calculator has the capacity, you can punch in square root and then make sure it's all in the parentheses, so that you're not taking the square root of part of it, but you're taking the square root of all of it. So 800 times 0.76 times 0.24, and then I close the parentheses. So you should be getting 12.0797351. So in which case, the standard deviation would be 12.08. Okay, very
Thank
nice. Excellent. Excellent. Allegra, does that help?
Yeah, thank you.
Perfect. You're very welcome. Okay, what's next?
Could you go through like 26 or 27? I think they're kind of similar.
Yeah, 26, 27. Love it. Let's do 27. That'd probably be cool. So for 27, it says for the standard normal distribution, what is the probability that 0.12 is less than Z, which is less than 1.47? So essentially what we're doing with this is we need to use our standard normal curve. We need to use our Z-score table. And again, if you need this for any particular questions, I will have your charts available electronically for you. So what I'm going to do is I'm going to switch over to my notes because I want to show you the process that I personally would take. Anna, do you have a quick question?
I had a question about having us do another one, but I can just ask it after.
Okay, perfect. So let's switch over to my notes. Don't mind the trigonometry that I was doing. So we have our standard normal curve. We know that we always label this 0, 1, 2, 3, -1, -2, -3. And according to the question number 27, this is one we're doing from our course review packet. It says, what is the probability that 0.112 is less than Z, which is less than 1.47? So what I want you to think about is your Z scores, right? What's the likelihood that your Z score will be between these two values? So 0.12, it's right here to the right of 0. And 1.47 is almost at the halfway point between 1 and 2. So we go ahead, we draw our dotted lines just so we have a visual here. and we are asking to find the probability that our z-score will fall within this range. Okay, so far so good. The next thing we're going to do is we need the z-score table. So I'm going to go ahead and open up my z-score table, and I hope you have your z-score tables as well. You can also find that in Lumen. I'm going to open mine up. So let me go into my stats materials. Math 160 tables combined. And I've got my z-score table. I will share this screen as well, just so you can see the process. So we are going to look for two z-score values. We want to look at 0.12, so 0.12, that's on the positive side, and so is the other guy. So 0.12. So that means we're referring to this value. The table provides the area to the left of that z-score. So the area to the left of a z-score of 0.12 is 0.54776. I'm going to do the same thing by looking up the z-score 1.47. So 1.4, we're going to go over to 7, here it is. So the area to the left of a z-score of 1.47 is 0.92922. Beautiful. What we will do now is, yes, Alessia, this meeting is being recorded and I will paste the link in Lumen, so no worries. So now I'm going to subtract those two values. And we're going to choose the option that best suits us. So let's go ahead and take the 0.92922 and subtract 0.54776. When I subtract those two, it gives me a probability equal to, I guess I'll write it out again, equal to 0.38146. And again, I subtracted these two values so that I can get the region right in between. When you take a look at number 27, that directly corresponds to option B. All right. Does that help at all?
Yes, thank you.
You're welcome. You're welcome. Anna.
So also with that part, it doesn't have it where the 6 is it, and it's not rounded. So it's just the 3.3814. So
That's
in
for the answer key, that's okay.
no, like for the multiple choice, it just has it to the 4 decimal,
Yes,
but it's not rounded.
Right, and that's okay. It's the closest value.
Okay.
So even if you didn't see that 6 there and you just saw this part instead, go for it, because that's the closest value, even if it's not rounded.
I have a few. Can we do like 28 or 29?
Yes, perfect. So let's start with 28. For the standard normal distribution, what is the z-score associated with the 40th percentile? Okay, a couple of things to think about when you think of the 40th percentile. First off, if you have your standard normal curve, you know that halfway through the curve is 50%. So this would represent, if I shaded everything to the left, that would represent the 50th percentile. But we want the 40th percentile. So we know it's somewhere to the left of 0, which means it's going to be a negative z-score. We just have to figure out what that score is. That's our responsibility. So we know that somewhere to the left of 0, when we fill in this area, that represents 40% of the data. That represents 40% of the population, which, by the way, is the same as an area of 0.40. What we will do now is we are actually going to go to the z-score table. So let me share that again. And we want to find the z-score corresponding to an area to the left of 0.40. When we drew the curve, we recognized that it was a negative z-score. So somewhere in here, we're going to find an area of 0.40 or as close to it as we possibly can. Notice as and I'm going to blow this up a little bit so you can see this better. As I'm scrolling through, I see areas 0.42, 0.41, 0.41294, 0.409050. We keep going, aha. An area of 0.40 falls right in between these two values. Now we have to decide, am I closer to the 0.40129? Or am I closer to the 0.39743? To figure out which one you are closest to, subtract 0.40 from each. So in our calculators, we're going to type in 0.40129 and we're going to subtract 0.40, which means the area to the, the z-score on the left will have a difference of 0.00129. So let me write that on the screen somewhere, just so that we have it. So the left side was 0.00129. Let's look at the area from the right. So if we take 0.40 and this time let's subtract 0.39743, that's going to be a difference of 0.00257. So I noticed for a fact I am closer to the area on the left than the area on the right. So we're going to say that the z-score associated is negative 0.2. Let's scroll up. 5. Here's your hundredth. So it's a negative 0.25. And that's a z-score of negative 0.25. And that's how you would find the associated z-score. Okay. And that is option D. 29 is the exact same idea. It says find the z-score, which is the minimum for the top 10%. What I'll do for 29, because I want you to try this out on your own, is I'm just going to simply draw what it's suggesting. Find the z-score, which is the minimum for the top 10%. So here's what your curve is going to look like. Here we have our curve. And we want to know the z-score, which essentially isolates the top 10%. If this area here represents the top 10%, then we know that this area represents the bottom 90%. So this is the bottom 90%. As a reminder, your z-score table gives you the area to the left of a z-score. So what you're going to want to do is you're going to want to find the z-score whose area to the left is 0.90. And that will help you to discern the appropriate z-score value. Another thing you could do is, because your test, or because this is multiple choice, you can actually test the values that are given and see which one has an area to the left. You already know for number 29, let's take a look at this. You already know for number 29 that your z-score is going to be positive. So B is gone, D is gone. You're essentially going to say, is it option A or is it option C? Which one has an area to the left of 0.90? Okay, and then you'll be able to make that decision.
Wait, how do we know if it's not negative, that we can take out the negative answers?
Because look where my z-score is.
Oh, if it was on the left, it could be
Negative.
negative.
Yes,
Okay.
just like here. So we knew that our z-score was to the left of 0 because this is 40% of the data. It was to the left of 50% since it's smaller. Notice that this is 90% of the data. So our z-score is definitely going to be a positive value. Cindy, then Anna.
I might be confusing this with another time that we used this curve, but wasn't there a way that you could find to the right if you did 1 minus whatever that z-score was for the left?
Yes, always, always,
Okay.
always.
Would that still be applicable for this kind of problem as well?
Not for this one, only because you were actually given the area and then you want to
Okay.
match it to the z-score. But if we, for instance, had, and I'm just going to write an example here. So let's say that the example was find the probability find the probability that your z-score is greater than, we'll do 1.50. So this is the idea where you first find the area to the left of the z-score and then you subtract from 1, since that'll give you the area to the right. This is exactly that experience. I'll demonstrate this one really quickly since it won't take us much time at all. Z-score of 1.50, here's 0, here's 1, here's 2, here's 3, -1, -2, -3. 1.50 is right here. We want to know the probability that Z will be greater. So we want to know the area in the shaded region. However, the Z-score gives you the area to the left. If you go to your Z-score table and you looked up a z-score of 1.50, you will see that the area to the left is 0.93319. So Cindy, when you said to calculate the area to the right, do you subtract from 1? Absolutely. 1 minus 0.93319 gives you the area above, which is 0.06681. So the likelihood that your z-score will be greater than 1.50 is 0.06681. That's the likelihood. Awesome. Anna.
Okay, so on the formula, the questions where it was like the mid quartile, the IQR,
yeah,
like those kinds of questions, can we go over one of those, like the whole, like you have to find the third, or like those whole type of.
Sure. Let's see if, does anyone see one on the review packet by any chance? Quartiles, let's see. Okay, let's go to one from Lumen. All right, we want to do quartiles. Let's see where this is.
There's sort of what is one in the course packet. It's a box plot that asks you to approximate the range and 5-number summary.
Which number is that?
It's 53.
Thank you. You're awesome.
And 54.
Okay, score 53 and 54. Awesome, I love it. Okay, perfect. The only thing with 53 and 54 is you don't get an opportunity to actually calculate those, to calculate the quartiles. So I think I want to pull a question that asks us to do that. So let's take a look at a set of data. Here we go. Okay, so I'm going to share my screen once more and we'll walk through it. Here we go. Given the following set of data, we have our 12 pieces of data here. We want to calculate the 5-number summary. All right, step number 1, we want to list all of our values from lowest to highest. So let's do that together. Let me go ahead and annotate the screen just so that we can list these values from lowest to highest. All right, we'll start with our lowest, which is 73. What's my next highest value?
185, I think.
Perfect. The next one?
226.
After that?
238.
238.
Okay.
281.
Okay.
391.
391. Yep.
482.
482.
510.
510.
699.
99.
699.
768.
768.
794.
794.
And then 916.
916. That should be 12 values. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Beautiful. There they are. What I like to do as soon as I see problems like this, I split them up. So I'm going to create a little bit of room. So we have the bottom 6 values and then the upper 6 values. Okay, I like to create that room there. Just think of them as a set of 12 values. Okay, first things first, I want to calculate the second quartile. The second quartile is literally the exact same thing as calculating the median. So when you consider finding the median, you're going to take your 2 innermost values in this case, because there's an even number, and you are going to add them and divide by 2. Okay, if there was one value in the middle, that would be your median, but this is a set of 12 numbers. So when we cut it in half, we have 6 and 6, which means that there are 2 values right smack in the center. So let's take our calculator. We've got 391 plus 482. Then we divide that by 2 to find the exact median. When you punch this in, you will see that your Q1 represents 436 your Q2, excuse me, represents 436.5. Remember that this is the same as calculating the median. So I'm going to write that here. So you can consider the second quartile is the same thing as the median. Okay, that takes care of that piece. Next, if you want to calculate the first quartile, you're simply going to look at the lower half of the data, the first 6 numbers in this case, and we want to find the exact middle. If we look at the lower 6 values, do you see that we have 2 values in the middle again, a 226 and a 238. So we're going to average those. Take your 226, add the 238, enter, of course, then divide by 2. And that tells us that our Q1, our first quartile, is the value 232. And we can double check that. There it is. So think of the first quartile as the halfway point of the lower half of the data. So halfway, or, I'm going to rewrite. I'm going to say the median of the lower half of the data. That's what your first quartile is. The third quartile is essentially the same idea, except it's the median of the upper half of the data, but it's the same exact process. So we have 6 values in the upper half. We're going to find the exact value in the middle, and unfortunately, not that it's unfortunate, but we have 2 values in the middle of the upper half. Add those 2 together. And then divide that by 2 to find that your Q3, your third quartile, is 733.5. And we can double check that as well, 733.5. Love it. In terms of your interquartile range, that is a formula that you should have on your formula sheet. To calculate the IQR, you're simply going to take the third quartile and subtract the first. So I'm going to write as Q3 minus Q1. That's going to give you your interquartile range. So you're going to take your 733.5, which is your Q3, and you're going to subtract 232, which is your Q1. So that should give you an interquartile range of 501.5. The last formula you need is to calculate your mid quartile. And according to the formula, in order to calculate your mid quartile, think mid like middle, so average. And you know how to take the average of 2 numbers, you add them and divide by 2. So to find your mid quartile, this time you're going to take your Q3 and add your Q1, and then you're going to divide that by 2. Okay, you're going to divide the sum by 2. So let's go ahead and punch this into our calculators. We've got Q3, which is 733.5, add Q1, which is 232, and then divide that value by 2 to find that your mid quartile in this case is 482.75. And that is how you calculate it by hand. Anna.
So is that the same if it was like an odd number, like if it was like
It's the
15
same exact
variables?
process. It's the same exact
Okay.
process. You simply find the median, that's your second quartile. Then you find the median of the lower half, that's your first quartile, and you find the median of the upper half, that's your third quartile. Once you have those three values, then all you need to do is use your formulas for IQR and for mid quartile.
Okay.
Good. Very nice.
And then can we go over one of the three on page 7?
Page 7, let's take a look. Okay. Awesome. Sandra usually jogs 2 miles per day. Based on 40 2-mile jogs, she computed a 95% confidence interval for her mean jogging time in minutes to be 15.23, 15.97. Which of the following statements is true with respect to the confidence level used? How would you describe what that confidence level is stating? What are your guys' thoughts? How would you describe that?
For oh my gosh, I can't read. So for the 42-mile jogs, those two numbers will fall under that 95% confidence interval, I guess.
Okay. All
In a
right.
long way of saying it, or never mind. I think I'll leave it at that.
I like how we're kind of thinking about what this is stating. What I think will be helpful to everyone is to consider the fact that she literally took 40 different jogs, and she performed the confidence interval test, right? She essentially said, let's calculate the interval which houses 95% of those jogs. So what she's saying is that for any jogs from this day forth, essentially, when it comes to her 2-mile jogs, that on average, they're going to be within that range. So which statement says this? So let's look at part A. Sandra is 95% confident that the interval from 15.23 to 15.97 minutes contains the sample mean. Well, that's not the point of her calculating the mean for 40 jogs, right? She's not trying to find an interval that contains the sample mean. She's trying to find the population mean. She's trying to figure out what it will be on average for forever, essentially, for all of her 2-mile jogs. So A can actually be tossed out. Consider that when you are calculating a confidence interval, you're estimating either the population proportion or the population mean. And that's what we're estimating here. So take a look at option B. Sandra is 95% confident that the interval from 15.23 to 15.97 minutes contains the population mean. And that's actually where we want to, that's actually the correct interpretation of that interval. Okay, it's not to say that, like look at part C, there is a 95% chance that the mean time for another sample of 42-mile jogs by Sandra will be between those minutes. That's not what she's saying. That's not what we're doing when we calculate when we estimate the population mean. We're saying that she's 95% confident that that interval will house the population mean. That's what we're saying. Hopefully that makes sense, that 31 is going to be B.
So how do we know that it's the population mean?
Because those are not proportions. Proportions are percentages. So for instance, if you thought that the likelihood that a certain garden will sprout flower A is between 23% and 28%. Those are proportions. Those are percentages. So 0.23 and 0.28, those are proportions. Do you see the difference?
Yeah, so since it's not a percent, but a decimal, it would be population.
And more than that, this is actually the mean jogging time in minutes. It's not a percentage. Like it literally says mean jogging time in minutes. So there's the great thing about that is there's no way to say, is this a percent? It's not, because it specifically states it's not. It specifically tells you what it is.
Okay.
Right? Good. Good. Very nice. Awesome. Let me make sure that I'm catching everybody else's questions. Okay, and I guess you can go again unless someone else has a question they'd want to throw in the mix.
I just had a really quick one, if you
Yeah,
don't
sure.
mind. So I'm looking at 23 and you don't have to go through it. I just want to make sure I'm doing it right. So what I would do is find the area to the left of negative 1.23, and then since it's asking for what's to the right, would I just subtract that from 1?
It's actually not asking to the right, it's asking to the left. Because it says
Oh,
what's the
okay.
probability that z is less than negative 1.23. So you would shade to the left of that z-score. So the table does give you that value exactly.
If it did ask for the right though, then I would subtract from 1.
That's good.
Perfect.
And the only way you'd know it we're asking for the area on the right is if it said the probability that z is greater than negative 1.23.
Got it. Thank you.
You're very welcome.
Real quick.
46. Oh, yes.
For 23, are we finding what the z-score, like the decimal is for that one, or?
They gave us the z-score. All we have to do is find the area to the left, which means you use the table.
Okay, so you use the table for that one.
Yes.
So you look for negative 1.23 on the table.
Yes. And Anna,
Okay.
that whole process is in the guided notes. So if you want to rewatch that video on the standard normal curve, I highly recommend it, because I think once you actually sit with it and kind of listen to that process, you'll see all the different types that are associated with the z-score, and it'll make a lot more sense.
Okay.
Awesome. Mani, 46 or 47? Let's take a look. Oops. 46 or 47? Cool. Okay. So we're essentially just matching Pearson correlation coefficient with its graph, right? So let me share my screen with you. One of the things, Mani, from our notes in Unit 7, there was an activity where I said, go check out Khan Academy. There was a link there. If you had clicked that link, it would have brought you to Khan Academy. And the great thing about that is Khan Academy has this practice assignment where you can actually move the correlation coefficient to the graph that you think it best represents. So Mani, I think a great strategy for you would be to go back to the Unit 7 notes, click that link in the PDF. If you open it up in Lumen, you can click it directly there, and you can play around with matching the correlation coefficient to the graph. So definitely check that out, but we can look at it together right now. Okay, here we go. So we want to match each of the following graphs with its corresponding linear coefficient. First off, for part A, is this a positive or a negative correlation coefficient for option A?
Positive.
Positive. What about B?
Negative.
Definitely, it's trending downwards. Option C?
Positive.
Positive. And then option D?
Negative.
Yes, I love it. Good. So we've got this idea of like positive flow versus negative flow. Okay. Now, in terms of trying to match which is which, think about correlation coefficient, correlation, the idea that two things are closely related. the closer you are to a +1 on the correlation coefficient, the stronger your relationship. So the closer to a line that relationship becomes, right? So as you move closer to a +1, it's a very strong positive relationship. So it almost looks like they're very close to an imaginary line. So what I'm going to do is I'm going to draw those lines. Just so we have an idea of what's going on here. So if I were to draw a line of best fit, I feel like it would be right about here. And let me make that a different color so it's easier to see. Will it change it? Of course, it's not changing it. That's okay. So let's do the same thing for our second graph. So here's the line of best fit right about there. We're going to do the same thing for our third graph. And we're going to do the same thing for our last graph. Perfect. Now, when you think about these particular images, do you see which one has the loosest correlation, the one that's not very strong at all? Which option would that be?
D.
D, right? So option D, as in dog, so option D has the kind of loosest relationship. It's not very tight. They're not closely related. So we see that there is a negative correlation, but also I want you to notice that it's kind of loose. So it's not very strong at all. So what that tells us is that if we had to decide which of these 4 choices would represent graph D, we would actually say that's going to be a correlation of -0.53. That's a moderate, it's actually a weak to moderate correlation between the two values. And we know that it's going downhill. It has that negative relationship. So as one increases, the other decreases, but it's not tight to that line. So we see it's a pretty loose relationship. Mani, does that make sense in terms of thinking about how to describe the correlation? Are you with me? Oh, yes. Okay, I see it. Beautiful. Okay. So then we look at the others and we're thinking, okay, so these all seem to have a tighter relationship. It's pretty crazy to think that like we're trying to match a correlation of 0.89 versus a correlation of 0.82. Those are both positive. So we're looking at either option A or C for the first 2 blanks. Which one has a stronger relationship? Which one seems tighter to the line? Option A or option C?
A.
Yes, option A seems like it's tighter to the line, like there's a stronger relationship. So if I had to guess, I would say that the correlation coefficient of 0.89 would be option A, which means the correlation coefficient of 0.82 would be more like option C because it's not as tight to the line. And then that leaves us with option B, a -0.83. Notice the values are pretty closely aligned to our line of best fit. They're pretty close to it, right? So also notice it's decreasing. So as one value increases, its corresponding value decreases. So we can say, you know, feeling pretty confidently that that's going to be the -0.83. Okay. Any questions on that?
I have a quick question.
Yes.
So I never like really understood these. So if it's a negative number, then it's going like B and D. And if it's a strong positive, it's going to be the higher number.
Yes. So essentially you have a range of values that your correlation coefficient can take on. And that goes from anywhere from -1 to +1. And actually, I'm going to do something better than that. We have this in our Unit 7 notes. So let me open up the Unit 7 notes and show you the graph because I think that's going to be really helpful to you. Oops. There's a lot of stuff that's still on the screen. Perfect. There we go. Okay, here it is. On the bottom of page 4, you have your scale of numbers. So if your correlation coefficient was 0, you basically can't really infer any linear relationship. So we say that it appears to be no significant linear relationship. We don't know what kind of relationship that is. But as you move closer to a positive one, your relationship gets stronger and stronger and stronger. So essentially, as one increases, the other increases as well. And it appears to happen at a very close rate the closer you get to 1. So that describes the relationship between the two values. The closer you get to -1, the tighter it is. But again, -1 means as one increases, the other decreases, which is why we have that negative trend. It's almost like negative slope, right? But you can still be strong in either end, which is why when we look at our graphs here, we can say that for option B, we have a closer relationship between the two variables. It's tighter to the line of best fit than, for instance, graph D. Graph D is kind of a little all over the place, right? It's a little bit more scattered. So it's a weaker relationship. If we go back to this idea here, a correlation coefficient of -0.5 is a moderate correlation, right? It's a moderate negative correlation. So they're going to be a little bit more spread out. The closer to -1 you get, the stronger that relationship is. So it's tighter to that line of best fit. But it doesn't mean that there's anything wrong with having a negative versus a positive correlation. Does that kind of make more sense?
Yeah.
Okay, good. And this is the exact set of notes where I want you to click the link. So check it out right here. So let's look at Khan Academy again to practice describing scatter plots. You can practice estimating the correlation coefficient. Click on these links. Try them out. Play around with these links, and then you'll be able to actually, you'll be able to see what the examples are. You'll be able to try this out on your own, et cetera, et cetera. Because these are my PDF notes, I wasn't able to click on the link. If you go into your notes and you click on your guided notes, let's go into unit 7. And what was that, page 4? No, it's not. It's right here, page 6. You can click this link directly from the notes and look what happens. It brings you right to the example. So you can actually, you can test it out. You can say, maybe this one's, you can move these values around and kind of get a better idea of which is which. It's a lot of fun. I would highly recommend that you try this out. Look at scatter plot B. Anna, do you see scatter plot B? Look at this nonsense. This is crazy.
So for that one, it would be negative and it would be the lowest one.
Yes, because it's
all like not together.
Yes, it would be the weakest relationship. Awesome. Yeah, absolutely.
I finally understand this part.
Good. Okay, go to Khan Academy, play around with it, because I think you'll like this. For scatter plot A, is it trending upwards or downwards?
It's positive. So
yes, positive. Scatter plot C?
Going up.
Yep. Scatter plot D?
Going down. So
yeah.
Negative.
Yes. Perfect. And now you just have to think about that relationship. Scatter plot D looks pretty tight against the line of best fit. So does scatter plot C. Scatter plot A seems a little loosey-goosey, right? It is positive, but it seems pretty loose. So
that one would get the second like highest.
Yeah, so I would go for that guy. We said scatter plot B was negative 0.3. So scatter plot A of 0.68, that's pretty good because it's pretty loose. And then we still have C, which is positive, and D, which is negative. So looking at those, we can say D was negative and C is positive. So a correlation of 0.88, that's a strong positive correlation. And I would say, yes, I totally agree with that. Scatter plot D is a strong negative relationship, and here it is.
I mean, it's stronger than scatter A, but it's still not like, because there's somewhere it's like a little farther, but that's the only strongest positive one.
Yes. So I like how you're estimating this. I like how you're thinking about it. The only way for your correlation to be a perfect positive one or a perfect negative one is if all the lines were perfectly on a straight line. If all the points, were perfectly on a straight line. And that's the difference, right? So we see that there's a little bit of variability here.
So like in the packet for 47C, that would be like the closest to a perfect one.
Yes, I agree. This is crazy close, right? This is crazy close. So out of these four options, which one would be option C?
Negative 0.93.
Perfect, beautiful. Very nice. Good, 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 good. I love it. Yay. 63, 63, 66. Let's take a look. Oh yeah, cool. All right, 63 has a lot going on, no big deal. I'm going to use my scrap paper to do this one. 63. So the PIQ, or Pritchard's Intelligent Quotient scores, are normally distributed, that's very important to note, with a mean of 120. So our mean, our mu is 120, and our standard deviation, our sigma, is 10.4. So I hope everyone's looking at 63. That's the one we're doing together. It says, what is the probability that a person selected at random has a PIQ score greater than 135? One of the things that I want you to consider, and I'm actually going to switch to my notes and describe this. So one of the things I want you to consider here is the fact that when we are asked to calculate the probability that a person's score is greater than 135, that's not a z-score. 135 is not a z-score, okay? That's not how that works. I want you to think of first the z-score formula. And who has the z-score formula for all of us? You should have it on your formula page.
Is it the X with the line over it minus like the U?
You're actually referencing the z-score used for the central limit theorem. Let's go for the more basic z-score.
X minus mean divided by standard deviation.
Yes, perfect. X minus the mean divided by the standard deviation. Beautiful. So when we are told for 63 part A, find the probability that someone selected has a score greater than 135, they're actually asking for this. They want to know what's the probability that X from your formula is greater than 135. So that means we have to use the z-score formula. We have to plug in our values. So let's do the work. We've got z is equal to X, which is 135, minus the mean, which is 120, divided by the standard deviation, which is 10.4. So let's go ahead. 135 minus 120, press enter, divide by 10.4. And we're going to round the z-score to the nearest hundredths, 2 places after the decimal. So my z-score in this case is 1.44. What we are going to do now is we're going to draw our curve. We always draw the curve. By this point, I feel like you guys have drawn the curve like a million times. So here's our curve. We're going to plot the z-score of 1.44. That's approximately here. We're going to draw our dotted line up. And then we want to know the probability that X is greater than that value. So we want to know the area to the right. But as a reminder, the table only gives us the area to the left. So we're going to go to our z-score table. And we're going to look up a z-score of 1.44. 0, 1, 2, 3, 4. If you look up the area to the left of a z-score of 1.44, you should have 0.92507 as your area, 0.92507. Does anyone have any questions on that? How I found that z-score? Okay, perfect. And then to find the right side, you're going to subtract from 1. So 1 minus 0.92507, that will give us the area to the right. So that's 0.07493. And that's your probability. Keep in mind that probability must be between 0, and 1. Probability cannot be smaller than 0. Probability cannot be greater than 1. So if you are coming up with an answer that's smaller than 0 or bigger than 1, you need to stop yourself. Probability cannot be outside of that range. Okay, and yes, we can. I'm going to stop this session 15 minutes before 4 so that I can have conversations with a couple of you need to check in and talk about certain things. Okay, so we're going to stop this at 3:45. Okay, so let's go back to the next part of 63. 63B says, what is the probability that an individual has a PIQ score between 104 and 126? That process is identical. The only difference is we need to find 2 z-scores and then calculate the area between them. So we want our PIQ score to be between 104 and 126. Okay, so you're going to calculate the z-score for each of these values. We have 104 minus 120 over 10.4. And we also have 126 minus 120 over 10.4. So we need to find both of those z-scores. Mohammed, is this okay so far?
Yeah, I was just wondering if when you draw the distribution, is there ever a time where you would like take the mean it gives you 120 and the standard deviation and then base the table off of that?
Like using the empirical rule. You can if it specifies using the empirical rule, but if it doesn't, then you'll want to use the z-score table.
So it'd just be 1, 2, and 3, and then -1, 2, and 3 instead of like 120, 130.
Right, yes.
Okay.
Because these values here represent z-scores and they represent standard deviations from the mean. So for instance, this is 1 standard deviation above the mean. This one here is 2 standard deviations below the mean, right? But that is the same as saying a z-score of -2 or a z-score of +1. Okay, so that's what those values would represent.
So you would use the formula the most.
Yeah. Oh yeah, for sure.
Gotcha.
Awesome. Once we find each of these z-scores, and of course round to the nearest hundredths place, -1.54 and 0.58, what you'll do for part B, and I'll let you do this on your own, is you want to calculate the area between those z-scores. So if I were you, I would draw the figure again, or draw the curve. We have -1.54, which is about here. And we have +0.58, which is about here. And then what you'll do is you'll calculate the area between, and that's going to give you the probability. Okay, so it's very much like a previous problem that we did with calculating the area between the 2 z-scores.
So you just find what's to the left of 0.58 and then what's to the left of 1.54 and subtract.
Good, perfect.
Gotcha, thank you.
You're welcome, you're welcome. For part C, the gifted program at Center Reach High School accepts students with a PIQ score in the top 10% of the population. So what score would a student need to have to be accepted to the program? That's directly related to problem number 29. So notice with 29, we want to figure out what the z-score is that pertains to the top 10% and the bottom 90%. Once you know the z-score, all it's asking you to do is calculate the x. Think about your formula. Z is equal to x minus the mean divided by the standard deviation. You have the mean, you have the standard deviation. All anyone has to do is give you either the z-score or the raw data value for you to be able to solve for the other one. So for part C says, find the z-score and then tell me what score does that associate with. Does that make sense?
Kinda.
Okay,
So
I'll give you an example. What if I told you that when you did the calculations that you found that your z-score was, I don't know, 1.555, right? Let's just pretend, and this is pretend, okay? We're saying that you found the z-score and it was 1.55. So then I say to you, well, what's the associated PIQ score? Like, what's the actual score that someone would get on that IQ test? And you would say, oh, no big deal. I know the z-score, which is 1.55. I don't know that score on the IQ test, so I'm just going to leave it X. I do know the population mean, which is 120, and I do know the population standard deviation, which is 10.4. So what I'll do in this case is I'll solve.
Oh, it's just reverse. I see.
Yes, which is kind of neat because you have the same 4 unknowns. As long as I give you 3, you can always calculate the 4th. Just to make sure we're all on the same page, the first thing you would do is multiply by 10.4. The reason being, this says x minus 120 divided by 10.4. The opposite of that is to multiply by 10.4. So we're going to do that to both sides. We have 10.4 times 1.55. That gives me 16.12. On the right-hand side, when we multiply by 10.4, it literally cancels out, right? Multiplication, division are opposites, so that'll cancel each other out. And we're left with x minus 120. So I just have to solve for x. We'll use the opposite operation again. I'll add the 120. And we just found the IQ score. Again, this is hypothetical. I'm not using the actual z-score that I needed for this problem because I want you to practice doing it. What I wanted to show you was what it might look like if you did have the z-score and you needed to calculate the PIQ, the IQ score for that test. We would say they would need an IQ score of 136.12. Mohammed, does that make sense?
Yep, perfect. Thank you.
Love it. You're very welcome. D is the exact same way, but instead of a 90-10, right, 90% of the population, 10% of the population, they're saying find the PIQ score at the 55th percentile. Draw the curve again. You know that the halfway point represents 50%. So Mohammed, is 55% of the data going to be lower than the mean or higher than the mean?
Lower or higher because it's on the right?
Yeah, kind of. If you know that this represents 50% of the data, well, where would 55% be? A little
Right
to
to the right of that, yeah.
Yes. So we need to figure out what that z-score is, such that the area to the left, all of this, is 0.55. So you have to find that z-score. And then you can calculate the associated IQ score using the
Gotcha.
formula.
Perfect. I don't want to take away from any other questions. If you could just blow past 66 really quick, or even just the first one for part A or something.
It's 66 part A. You're given the mean, you're given the standard deviation. So a random sample of 16 heights is obtained. What's the probability that one student selected at random is at least 70 inches tall? That's your z-score formula again. Right? So you'll calculate the probability by finding the z-score for someone who's 70 inches tall. If you filled in your z-score formula, what would go in for X for 66 part A?
The 70.
Perfect. What's your mean?
It's 68.
Any
70 minus 68. And then divided by 3.75.
Perfect. That'll give you your z-score. Then you look it up on the table. That'll
okay.
answer this one. Part B is not the same. Notice that part B says, what is the probability that the mean height of the 16 students sampled is at least 70 inches? So let me tell you the difference between part A and part B. Part A said, find the probability that that one student is at least 70 inches tall. So that one student, that raw data value is at least 70 inches tall. What does at least 70 mean?
Equal to or greater than 70?
Yes. So that means we need the right tail, right? Once you figure out the z-score, we want the region to the right. So keep in mind that that's what you're going to do for part A. For part B, it's asking for the probability that the mean height, so the sample mean, that's x bar, that is at least 70 inches. So it's the same idea, except your formula just changed. Your formula in this case, someone had mentioned it earlier, that's going to be your sample mean minus the population mean divided by the population standard deviation over the square root of n. So you're now using your z-score for the central limit theorem. Okay, but the cool thing is once you actually plug in all your values here, you still draw it on the normal curve, you still shade the area to the right, you still find the probability using your z-score table. Okay, Mohammed?
Gotcha. Yep. Thank you.
You're very welcome. Anna,
Can we do either 77, 78, or 79?
yeah, 77, 78, 79, sure. Love it, love it, love it. Okay, so let's take a look at number 78. I hope everyone's looking at that, and it really doesn't matter. So I just chose 78 because why not? So notice for problem 78, you're given the formula. If you look at the fitted line plot, it says answer time average in seconds. So we're going to call that our Y is equal to 247.9 minus 1.981 number of personnel. Number of personnel is X. When we think about this particular equation, I want you to think Y equals MX plus B. But more specifically, here's your MX. So this is your M, and here's your B. What does the M represent in this problem? This is our what? How do we describe M? That is our
Slope.
yes, here's our slope. How do you describe B on our graph? This represents our
Y-intercept.
perfect. So here's our y-intercept. So a couple things to know. Our y-intercept is always of the form 0, 247.9. Our slope is the change in y over the change in x. So our slope is negative 1.981, and we could write over 1 if we would like. So that's something to think about. Okay, so looking at problem 78, it says, A, what is the slope and what does it mean in terms of the data? Okay, well, the slope is negative 1.981. You do not need to write over 1. You can simply say the slope is negative 1.981. Now, when we think about what does it mean in terms of the data, what I would do is I would place this value over 1, and then I would dissect what this actually refers to. Remember that slope is the change in y over the change in x. That's delta y over delta x. According to this problem, our y represents the answer time in seconds. So I'm going to write here that this represents the answer time in seconds. The denominator represents x, and x represents the number of personnel. Okay, when we think about those values, what we can say is, all right, we have a positive 1 here. Okay, so maybe for every additional number of personnel, or you can say for every increase of 1 person. So for every additional person, what happens to the answer time?
It gets subtracted.
Decreases.
It decreases. Good. I think decreases would be a nice way to say it. And keep in mind that we're talking about the predicted answer time. So we could say that the predicted answer time in seconds decreases by 1.981 seconds. Okay, so for every additional person, the predicted answer time decreases, because it's negative, by 1.981 seconds. That's what that slope represents. The next thing we're asked to calculate is the y-intercept, which we already found. The y-intercept is 0,247.9. But now we want to say, what does it mean in terms of the data, and is it meaningful? When we look at our ordered pair, 0,247.9, I feel like it's going to be really important to, again, match the language with the values. So the 0 here refers to our X, and X is the number of personnel. Our Y represents the answer time in minutes, the predicted answer time, excuse me, in seconds. I didn't mean minutes, in seconds. So that's kind of an interesting statement here. If we're trying to interpret the y-intercept, so the y-intercept is 0,247.9. What do you think that means? We have a 0 number of personnel, and then we have 247.9 for the answer time. How would you write a sentence that interprets this y-intercept? How would you describe that? Does anyone have an idea? It's kind of weird, but go with the numbers that you have here and use the language from the actual problem itself. What might you say?
For every 0, it sounds so weird, but for every 0 number of personnels, the predicted answer time will be 247.9 seconds.
You are so close. I'm going to tweak that a tiny bit. And the only reason is when you say for every, particular value, you're actually referring to slope. This is actually a point in time. So really what this means is when there are 0 personnel, or when no one is working, right? So when there is 0 personnel, which by the way means no one's working, or when no one is working, the predicted answer time is 247.9 seconds. But what are your thoughts on that statement? What do you think of that statement? Is it meaningful or is it not? Tell me why.
I don't think it's meaningful.
Yeah, good. Why?
Because it doesn't make sense that you would have an answer time if there's nobody working.
Done. Done. That's exactly it. If you responded in that way to that question, you get 100% for that, because that makes total sense to me. You're saying no one's working. So how can there be an answer time if no one is working? So you can say exactly that. Is it meaningful? No, absolutely not. That doesn't even make sense. Okay, when no one is working, there will be no answer time because no one's picking up the phone. Okay, so that's exactly okay. You can say 0 is not in our domain, right? If you don't have anyone working, you don't have an answer time. So 0 is definitely not part of our domain. But I would totally accept the language that Cindy, you provided, because it's very clear and it makes total sense. Okay. All right. And on that note, I am going to let you go. Please do not forget that you have 2 other review videos that are in Lumen. Be sure to watch those. And if there are any weak areas that you'd like to tighten up, go back to those videos. Go back to the guided notes. I have everything filled out for you. Check it out. Click the Khan Academy links and play around with that as well. All right. Excellent work, everyone. I will see you all tomorrow at 10 a.m. for the part 1 of our Lumen final exam. Thanks, everyone.